El Nino, La Nina, or La Nada, now on Weather Medic's Weather Buff. I am Jack Kanak, the Weather Medic, the Doctor of Weather, with your April 2023 El Nino, La Nina, or La Nada forecast discussion. Well, for a synopsis, ENSO neutral conditions are expected to continue throughout the Northern Hemisphere spring, followed by a 62% chance of an El Nino developing during May through July 2023. Right now, we're going to talk about the Nino regions. Here's a map of the Nino regions, and we have from the upper right-hand corner, the United States, Central America, further to the south, South America. Then you have the North Pacific Ocean, Hawaii, South Pacific Ocean. As you move toward Asia, you have New Zealand, Australia, Papua New Guinea, the Philippines, and Japan. So let's talk about what the Nino regions are. Nino regions 1.2 are the area by South America between 0 and 10 degrees south latitude and 80 to 90 degrees west longitude. Nino 3, which is this red outlined region here, is between 5 degrees north and south of the equator, and also between 150 degrees west longitude and 90 degrees west longitude. Nino 3.4 combines the Nino 3 regions and Nino 4 regions, and that's located, once again, 5 degrees north or south of the equator and 170 degrees west longitude through 120 degrees west longitude. And finally, the Nino 4 region is located 5 degrees north or south of the equator in latitude and 150 degrees west longitude through 160 degrees east longitude. During the last month, above average sea surface temperatures became more prominent in the western and far eastern equatorial Pacific Ocean. So we're talking here, and we're talking especially here off the coast of South America. The latest weekly Nino 3.4 index value was 0. But the Nino 1+2 index value was a whopping 2.7 degrees Celsius or 4.9 degrees Fahrenheit to the positive, indicating significant warming along the South American coast. The diagram here on the top is the area average subsurface temperatures. They also increased during the past month, reflecting the dominance of above average subsurface temperatures across the equatorial Pacific Ocean. Look at all the warmth of these subsurface temperatures right here. Whole thing is warm, especially along the South American coast, where you're seeing temperatures very warm. For the monthly average, upper level and low level winds were near normal across most of the equatorial Pacific Ocean. However, low level westerly wind anomalies were evident in the first half of March associated with sub-seasonal activity. Suppressed convection was evident over the central tropical Pacific and over parts of Indonesia. While the warming near coastal South America was striking, the basin-wide coupled ocean atmospheric system was consistent with ENSO neutral. We're right here right now, very close to the 0. El Nino threshold is a half a degree Celsius above normal. La Nina threshold is a half a degree Celsius below normal. Why do we think El Nino is coming? Well, let's start talking about a Kelvin wave and the Madden Julian oscillation. Let's first start with the Kelvin wave. The waves that most of us are familiar with are the waves at the beach, waves that endlessly curl and crash on the shore. But the ocean and atmosphere also have what are called planetary waves. These are waves of massive and immense scale. Kelvin waves are a kind of planetary wave. Unlike the waves at the beach, Kelvin waves do not curl over and then crash. They are more like the waves in your bathtub, which slowly slosh around. They don't break, but they still have broad peaks and valleys that change the depth of the water. The ocean equivalent is sea surface height. The Kelvin waves that are relevant to ENSO and this video only move eastward and along the equator. Like all planetary waves, the geographic extent of an equatorial Kelvin wave is huge, often stretching over much of the Pacific Ocean, thousands of miles. Equatorial Kelvin waves have two phases, which can lead to very different changes in subsurface and sea surface temperatures in the eastern tropical Pacific. What you're looking at here in this diagram is a downwelling phase of the Kelvin wave. You have here surface depth in meters along the y-axis, or you have depth of feet in meters here. And also you have the temperature scale is colors here on the bottom. And also what we have is the time here is on the left-hand side of dates and time. This is going from February all the way to April of this year of 2023. And what's happening is with this downwelling phase of the Kelvin wave, that normally winds blow from east to west across the tropical Pacific, which piles the warm water in the western Pacific. So the air is moving normally at the surface this way. So you have that piled up, that warm water piled up on this side of the Pacific over here. Well, what happens is that a weakening of the wind starts. The surface layer, as this weakening diminishes, this surface layer that's piled up on this side, it starts cascading eastward. And that's what we're looking at here. We're looking at this cascading eastward. The thick, warm layer sloshes east, pulling down the thermocline as it goes. Thus, we call this a downwelling wave. The thermocline is actually the boundary between the warmer, near-surface mixed layer and the colder, deeper water. Scientists use the subsurface temperature of about 20 degrees Celsius or 68 degrees Fahrenheit to define the boundary of the thermocline. Around the 20 degrees Celsius or 68 degree Fahrenheit layer, ocean temperatures change rapidly, a strong temperature gradient. On average, the thermocline is found at a deeper depth in the western Pacific and is closer to the surface in the eastern Pacific. So that's what you're seeing here. See how this wave is going like this? Because that's kind of how the thermocline is going. Because of this downward push as the wave travels eastward, it is harder for the colder, deeper water to affect the surface, so near-surface temperatures are often above average. This will often, not always, warm the surface temperatures and plant the seeds for an El Nino. Well, the other phase is an upwelling phase. Sometimes after the downwelling part of the wave goes by, we sometimes, but not always, see a rebound or upwelling where there was once downwelling here. The colder water at depth upwells and the thermocline becomes closer to the surface. We often will see below average temperatures near or at the surface. The question is, are we going to have an upwelling phase following the downwelling phase? But right now we don't think so, but stay tuned. The Madden-Julian oscillation. So unlike ENSO, which is stationary, the Madden-Julian oscillation is an eastward moving disturbance of clouds, rainfall, winds, and pressure that traverses the planet in the tropics and returns to its initial starting point in anywhere from 30 to 60 days on average. This atmospheric disturbance is distinct from ENSO, which once established is associated with persistent features that last several seasons or longer over the Pacific Ocean basin. There can be multiple Madden-Julian oscillation events within a season, and so the Madden-Julian oscillation is best described as intra-seasonal tropical climate variability. Well, here are my reasons that I feel we'll have an El Nino this fall of 2023. First, the latest runs from many different computer climate models are providing very high probabilities that El Nino will develop this year. When there's a lot of an agreement among the different models, I tend to give more credence to their predictions. But it's not just model advice supporting the forecast. I always keep an eye on the temperature of the water under the surface of the tropical Pacific. After many months of cooler than average, the amount of warmer subsurface water has increased over the past month as that downwelling Kelvin wave that I showed you just a few minutes ago, an area of warmer water that sloshes from west to the east beneath the surface traverses the tropical Pacific. Further bolstering the chance for an El Nino is a short-term forecast for this Madden-Julian oscillation just described. The Madden-Julian oscillation is an area of storminess that, of course, once again travels west to east along the equator. It's flanked by wind anomalies as surface level winds rush toward the area of storminess. The Madden-Julian oscillation is predicted to be in a phase that will weaken the trade winds, the consistent east to west winds near the equator over the next couple of weeks. Weaker trade winds allow the surface to warm and can contribute to the growth or propagation of downwelling Kelvin waves. One more observation supporting the potential development of El Nino is the currently very warm far eastern Pacific. The Nino 1+2 index shown earlier in this video, which measures the sea surface temperatures off the coast of Peru, was near record warm in March. A coastal El Nino like this can precede a larger El Nino event, although not always. While the lower accuracy of forecasts during the spring can result in surprises due to the spring predictability barrier, the recent oceanic Kelvin wave plus recurring westerly wind anomalies are anticipated to further warm the tropical Pacific Ocean. The coastal warming in the eastern Pacific may foreshadow changes across the basin. Therefore, an El Nino watch has been issued, and the range of possibilities toward the end of the year includes a strong El Nino, a 4 in 10 chance of a Nino 3.4 region greater to equal to 1.5 degrees Celsius or 2.7 degrees Fahrenheit above the average, to La Nina ENSO neutral, which is a 1 in 8 chance, to a 1 in 10 chance of a La Nina again. So, in summary, ENSO neutral conditions are expected to continue to the northern hemisphere spring, followed by a 62% chance of an El Nino developing during the May, June, July 2023, and an 80% chance of an El Nino developing by the fall. So that's in this area here. Here are maps of the El Nino related pattern temperatures, patterns for June, July, August. El Nino influences the Atlantic and Pacific hurricane seasons, usually leading to fewer tropical storms and hurricanes in the Atlantic and more than average in the Pacific. In the case of the Atlantic, El Nino increases vertical wind shear. That's the change in wind direction and strength from the surface to higher in the atmosphere, which can impede a hurricane's growth. Hurricanes are normally going this way, and then they come up the coast, okay, or they go into the Gulf of Mexico and then create havoc. But what's happening is that you have first warm and dry air. This is the brown color here. Warm and dry. And dry air tends to impede a hurricane. Plus, since the winds are weaker and not blowing this way like it does normally, and it's less, the winds blow a little bit more toward the west. And when you have west and east, what's happening is that it's tearing apart the hurricane development. So that's why we have less hurricanes in the Atlantic basin. Of course, NOAA's hurricane outlook comes out next month. I will put out a video forecast when this comes out as well. Also, I wanted to mention that in Peru and Chile, you have conditions that are warmer than normal, as well as in parts of Brazil. And also in the southern part of Chile, you have wetter than normal conditions as out in the Central Pacific, but they're fish storms and nobody cares. Cool and dry weather in northeastern Australia and parts of New Zealand. And then we have the last thing, drier than normal conditions. That's this color, and that's in the eastern part of Australia going into Papua New Guinea and also parts of India. Now let's look at the El Nino pattern for December, January, and February. Let's start with the areas that are cool and wet, because those are the ones in the southern United States, from Florida going all the way through Texas, cool and wet. It's going to be areas of just wet weather in the desert Southwest. We get some storms in California within El Nino, and also wet conditions in eastern Brazil and Argentina, as well as China and Taiwan, and also in the South Sudan, looks like Kenya and Rwanda. Let's talk about areas that are warmer than normal, and those are going to be in southern Alaska, into the Yukon, British Columbia, Western Canada, going into the states of Washington, Montana, Idaho, and into the parts of the Dakotas are warmer than normal, as well as Japan, Korea, India, and parts of Laos and Thailand, and also southeastern Australia, and also parts of southeastern Brazil. Let's talk about the warm and wet regions. That's going to be stretching along the equator where the El Nino is present, from the Nino 1.2 regions here off the coast of South America, all the way across the Pacific, almost to Papua New Guinea. And then once we get into the area toward Papua New Guinea, and we have dry conditions in those Papua New Guinea, out where Hawaii is, and also into northern Australia, dry conditions over northern Brazil, with the conditions that are warm and dry. And that's going to be parts of Papua New Guinea and going into Indonesia and also Southeast Africa, including South Africa, Botswana, Zimbabwe, and into Mozambique and Madagascar. ENSO has a strong relationship with the global average temperature. In general, the warmest year of any decade will be an El Nino year and the coolest a La Nina one. In our historical record dating back to 1950, we have not gone more than 4 years in a row without an El Nino. If we don't have an El Nino in 2023, 2024, that will be 5 years. ENSO forecasts made during the spring are less accurate, and also the tropical Pacific atmosphere is still fairly consistent with a cool La Nina-like state. However, it is possible that strong warming near South America may portend a more rapid evolution toward El Nino and will be closely monitored. In summary, La Nina has ended and El Nino southern oscillation neutral conditions are continue to be expected through the Northern Hemisphere spring and early summer 2023. The next monthly video on the El Nino Southern Oscillation will come out on or around May 12, 2023. If you would like to see more of these posts or would like to say thanks for this one, please consider becoming a supporter. To support the channel, go to patreon.com/WX Medic. This is Jack Knack, the Weather Medic, the Doctor of Weather. Thanks for making Weather Buff a part of your day. Good day, everyone.
Weather Buff. Your backyard.